Hello and welcome to this fifth lecture, Algorithm Selection and Development in this course, Master in Artificial Intelligence. So in this particular lecture, we will talk about how does one calculate Davies-Baldwin index and how does it compute average similarity between each cluster and its most similar clusters. We're talking about clustering. And to recap, we are in the middle of talking about how to determine the type of outputs in evaluation matrices. And particularly, we are talking about clustering type of output and their evaluation matrices, the second being the Davies-Baldwin index. So, how does Davies-Baldwin index compute the average similarity between each cluster and its most similar cluster? So it is this DBI or Davies-Baldwin index is another matrix used to evaluate the quality of clusters in a clustering algorithm. So it evaluates how good a clustering algorithm is. And it measures the average similarity between each cluster and its most similar cluster. And how does it compute this similarity? Let's take a look at it in detail as we go forward. So for each cluster that you see here, it computes the centroid, you compute the centroid Ci, right, for the cluster I, which represents the center of the cluster. So you calculate centroid Ci for each cluster I. Then other cluster J, where J is not equal to I, you calculate the average distance between each point in cluster I and the centroid Ci, and this is denoted as average I. So that's the average distance between each point in cluster I and the centroid Ei. Similarly, you calculate the average distance between each point in cluster J and the centroid Cj, and it is denoted as average J. And then you calculate the distance between centroid Ci and Cj, and that is called Dij. Then you get on to calculating similarity between cluster I and J and most similar J by the figure called Rij, which is average I plus average J divided by Dij, as you see here. And the Davies-Baldwin index for the clustering is the average of similarity values Rij across all clusters. You got it? The lower the Davies-Baldwin index, better the clustering, right? Okay. Then let's look at how do you interpret the Davies-Baldwin index after having calculated or after having got it calculated by the computers. How do you interpret it? Now, a low Davies-Baldwin index, what does it indicate? It indicates that the clusters are well separated and distinct from each other, and each cluster is more similar to its own cluster than to others. So the clustering is proper. On the other side, conversely, a high Davies-Baldwin index suggests that the clusters are less well separated and may have significant overlaps, and that boundaries between clusters are less clear. So for any cluster algorithm, if you create a clusters and you get low Davies-Baldwin index, that means the clustering program is working well. Now, using how can you use the Davies-Baldwin index for cluster evaluation? Like the Shillard score, the Davies-Baldwin index provides a way. It provides a method to quantitatively evaluate the quality of the clustering algorithm. So it quantitatively evaluates the quality of the clustering algorithm. Now it can be used to compare. You can compare different clustering algorithms or parameter settings of the same algorithm and to select the optimal number of clusters by using these techniques, the evaluation that we talked about. The Davies-Baldwin index complements other clustering evaluation matrices such as Shillard score and provides additional insights into the clustering quality. So that's how you can use the Davies-Baldwin index DBI for clustering evaluation. So in summary, the Davies-Baldwin index measures the average similarity between each cluster and its most similar cluster, provides a quantitative measure of the cluster quality in a clustering algorithm. A lower Davies-Baldwin index indicates better cluster separation and distinctiveness with much less overlap and uh, commonality between the clusters. So what is next? So we will look at last of the measures, last of the evaluation criteria for clustering, which is using the adjusted RAND index ARI and adjusted mutual information AMI measures as the agreement between the true labels and cluster assignments, the actual true labels of the clusters and the cluster assignments. That's what we will do in the next lecture. So thank you so much for watching this fifth algorithm selection and development lecture on clustering and evaluation criteria in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question and download the PDF file to take a closer look at some of the things that might interest you.